Alright, so this lecture is going to be on Chapter 12 from the book titled Exception Handling and Text Input Output. For this lecture, we're just going to focus on the first part of the chapter, which includes exceptions, what they are, what type of errors can occur with these exceptions. We're going to also look at the try, throw, catch exceptions, getting information from exceptions, what the finally reserved word is, and some general guidelines on how to use exceptions correctly. Now, before I get into that, I really want you guys to be familiar with this concept of exceptions. If in Java I tried to divide by 0, what would happen? Well, it depends on how I set it up. I can actually set it up where it shows me infinity, but in most cases I'll just get a runtime error. If I did a scanner object and I said scanner object equals and I created int. I said int I equals scan.next int, and the user types in a word, what happens? Have you guys ever tried that? You get a runtime error because you're trying to get something that is a string and trying to make that into an int, and the computer can't do that. So these are examples of runtime errors. And when we encounter these runtime errors up until now, we have no way of handling it. Now think about how valuable your software would be in the real world if every time a user encountered an error, they would just have to start their program over. It wouldn't be that user-friendly, okay? So this is what exceptions do for us. It gives us a way to handle these errors so that the software can continue. So we're going to talk about that today. And then the next part of Chapter 12 is just the file class, where how we can read data from a file, put data into a file, using the print writer and scanner classes. And that's also extremely important. When we talk about real software will generally write data to files or read data to files, and in most cases is doing both. But that will be on Monday. So let's talk about exception handling. So exceptions are thrown from a method. Let's make sure we understand that. If I have an exception, I got to make sure I'm throwing them from a method. And there's two ways to do that. The first way is to directly throw it by using a throw statement in a try block. That's similar to an if statement, and I'll demonstrate that later. And then another way is to invoke a method that may throw the exception. So in the second case, it's actually a two-part thing. The second case is I'm calling another method that does that first sub-bullet. So I'm calling a method that directly is using a throw statement in a try block. All right, so these are two different ways we can do exceptions. You have to understand that exceptions must have a message, otherwise no one knows what's going on. Think again, we're trying to create software that can be usable for people in the real world. If they encounter an error message, they need to know what happened and what they need to do about it. So we have to make sure we have descriptive messages that help users understand what happened, help users understand how to resolve these errors if they can. It also helps programmers and troubleshooters understand how to diagnose an error. In those cases, you'll see like an error code with a number or a long string, and if you call IT, they're asking you, what's the error code you're getting? So the real thing you need to understand is specificity is important. The more specific you are with your error message, the easier these three things can happen. If you just say, hey, you did something you weren't supposed to do, I'm going to crash, the user doesn't have a lot of information, and that's not really good software, okay? So here's a try block example. This is without a try first. So I'm asking the user to enter a double, and then I get a scan.next double. And let's say I put in a string. So I put a string instead of a double. Here's what I get for the output. Exception thread main is an input mismatch. It's expecting a double, but what I put in was a string. Java cannot handle that. So what I would like to do instead is create a try block that helps the software function in case of this error. So I surround the system.out.println and the double with a try statement. Immediately after that block, I say catch. Okay. So what this does, it tries to execute this code. It's called try for a reason. It tries to execute this statement. If it does, it moves on to the next statement. It tries to execute this statement. If it cannot, let's say for example, I put in a string, it says, oh, let me go here. Let me go here. This message here now goes, and this is what is part of this exception, and then I can just tell the user you're not putting in a number. Okay? But we're gonna actually come up with better ways of handling it. This is just an example. So here's a throw example. So I have a method. We're doing a division, and if I'm doing an if statement, so if I catch that b isn't 0, or if b is 0, I'm going to do this else statement and say, hey, you can't divide because the divisor is not a, well, it should say it's not a number. Divisor is not 0, or divisor should not be 0. That's what it should say. And then with the throw, you can see the difference. It's outlined in red, where I have the name of the method, and then I have throws exception. I still do my if the way I've done it before. In this case, in my else, instead of printing something out, I throw that new message. So I say, this becomes like almost a return. Throw the new exception, and that's the improper message, but it's going to throw that message. Okay? Any questions to that? Yes?
What's the advantage of doing it with a throw instead of just...
That is a very good question. So remember, real world software has pieces, and we put all our pieces, and something has to call these pieces. Usually that's a main. All right? It's better for the main to handle all exceptions. So you just want to, in the term is, you actually want to throw up to main. And whoever's writing main, they'll figure out how they want to handle their messages or those exceptions. Because in some cases, you may have to actually tell the user you're closing the program. In other cases, I still may need to do other stuff before I close the program. So it all depends on what happens in main. Okay? Catching errors. Let's see here. So I have so if I put these two guys together, the one on the right is calling the one on the left. Okay? So he calls inside the try block method with exception, which is this guy. And if he throws something, he's going to catch what is thrown. And then in here, I say, let me do that. Let me print out the message. And I'm also printing out the message from this guy. Okay? So in most cases, especially for your assignments, consider what's on the right to be main. Okay? And so you're going to have to do that in main on the right. And then on the left is going to be your methods that you write. And this will become very important in this chapter because we'll start working with files. The reason why we do exceptions first is you can't implement file classes without implementing exception handling. The file class requires you to do that. And as we get into UIs, we're going to have to make sure we know how to do exceptions as well in UIs, because we wouldn't want to close a UI just because a file that needed to be read doesn't exist. That would be really bad. And one more thing too. The reason why I'm not calling this guy main over here is once we get to UIs, we don't operate inside of main. We operate inside something called start. So I don't want you guys to just get so fixated on it has to be main. Whatever the launching or the invocation code is, whatever that method is, he handles all the error messages. All right. And let's see here. The last thing is how to get the information from an error, and this is pretty much just a repeat where this message here is what gets printed out in redacted message. Okay. So the book mentions 3 types of errors. The first one is a system error. Usually the system errors are the more fatal errors, and in those cases, it's better programming and better software practice to give the user a message prior to closing. I mean, it would really be bad software if you're doing something, all of a sudden, the application you're working in just crashed and closed, and you had no idea what happened. So it's much better to tell the user, hey, this has occurred, and I need to close. Okay? In those cases, the class we'll be working with is the error class, not the exception class, the error class. The second type of errors are runtime exceptions. So these can be fatal, and other times it could be non-fatal. And these are generally programming errors, and the book goes in a little more detail about what kind of programming errors it could be. And in those cases, they're represented by the runtime exception class. So I think this is where we'll do the whole dividing by zero, or taking something out of a scanner and it's an input mismatch. We'll get there, okay? And the non-fatal errors are the exception errors. When we encounter a non-fatal error, it is really important that we don't close and abort the software. Instead, we just need to have mechanisms to continue running the program. Okay, and this will be represented by the exception class. So make sure you know what kind of error you have and which class you need to use. Because in most cases, what you will be asked to do is write your own custom error class. So your custom error class will extend one of those three errors. Okay? Any questions to that? Okay, so now let's go into finally. Finally is a reserved word in Java, and it pretty much does exactly what it says. No matter what happens, the finally block will always get executed. So if an error is encountered in my try catch, we always include code inside the finally. If we don't have a finally, and let's say we had more statements that came after this catch, what would happen is we go into here, and let's say an error occurs, we go down here, and then the code completes because it has nowhere else to go. Even if we have more code outside of this catch, it won't get executed because we're inside this block and this guy's going to exit. With a finally, it helps us to now have the code continue. So if we're inside this try block, something happens, we go inside this catch, instead of exiting, we go to final. And we execute everything inside of finally, and then the code will exit. Okay? The reason why we have finally is once we start doing things with files, we need to always make sure we close the file before we abort our program. If I have an exception, let's say I'm trying to read data to a file, or I'm writing data to a file, whatever, and for whatever reason, I lose track of that file. Let's say I'm on the internet and I lose my internet connection. Before closing the program, I want to see if I can close that file. Okay, so let's make sure. We'll get to this more once we start working with files. But once we're working with files, or we're doing some internet connection, or even we're doing internet or user interface stuff, when we get to chapter 14, it's really important to have a finally set up for ourselves. Okay. So here's general guidelines, and this goes back to the question you asked. Whatever, and I'm referring it to as the main method, but it doesn't always have to be main. Whatever your launching code is, he should catch all exceptions. So we always put a try catch finally block inside our launching code. For this chapter, it will be main, but once we get into chapters 14 and thereafter, it could be in start or somewhere else, wherever's calling to the other things. And all your other methods will throw exceptions if they have to. All right, so I want to make sure I clarify that second point. You don't always have a method throw things if it doesn't have to. If you're using something like a scanner object or a file object, then yes, you should be throwing something. But if you're making a computation and you're not dividing by anything, then there's no need to have an exception. All right? You only need exceptions if you think something bad can happen that can cause an error. I don't expect for you guys to do this well now, but it's just helpful information to know. it's always better to use custom exceptions. So usually, and I usually did this when I started doing UI programming. I would have my own class and call it my exceptions and extended exceptions. And I would always refer back to that. I would always throw that type of exception. And the reason why I did that, it gave me more power on creating code that I wanted. And not only create messages that I wanted, but also I could handle messages or handle errors better by having that my exception class, a customized exception class. Okay? And then these are just different examples. One is a bad error message, error encountering code. That's not helpful for anyone. But here's a better one. Here's a code. That code can now be given to an IT support person. That IT support person can look up that code and say, oh, that's what this error message means. Then we can also have a line of code for the person. And then it's telling the user what's happening. And then we'll stop there because the file class will be discussed on Monday. So are there any questions? All right, that will conclude this lecture. This lecture will be on problem 1110 in the book. We're being asked to create a MyStack and use an array list implementation. If you guys can look back at the book, it first shows you it's referring back to listing 1110. So I'm going to go back to listing 1110 so I can show you what composition looks like. Alright, so here's the listing 1110 if you guys can, where are we at? So you guys can see it. So it already has the code here. We're going to pretty much do this, except we're not going to do composition. Composition is line 4. Alright, what it's saying is if you guys remember when we talked about composition, composition is a special form of a relationship where a class has something. So MyStack has as a member an array list. That's composition. What it's asking us to do is not use composition, but use inheritance. So how would we use inheritance instead of composition?
You would extend array list.
Exactly. Well, yeah, we have a public class MyStack extends array list. All right, so let me show you what that looks like in code. So I'm going to switch screens in a second. Just look at just lines 3 and 4. This is a composition where we have a class called MyStack that includes as a member an array list, and we operate on the array list. Look how we operate on the array list. And this is called the array list. That's the object is list. Everything we have is with the list. And with the inheritance example, it's going to look like this. Public, well, let me first import. Import java.util.arraylist, and then I'm going to create the class, public class, MyStack, and I say extends array list. So notice the difference. This is inheritance. Oh, you guys can't see that. I'm glad it took someone to lines 3 to tell me. Okay. All right, so you guys can see that now. So see the difference? I am now extending the array list. And because I've extended him, I don't refer to the list object. I'm going to refer to myself, in this case with this. Okay? So now I'm just going to type the code. You guys can't see me typing, or you guys will see the code that I'm typing, but you cannot see what I'm using. I'm just copying the code that I see in the book. So the first one is empty, and I'm going to type the code that's in the book, and I'm going to show you how I change it. Okay? Okay, so this is the first method, is empty. Now, again, the book is using composition. So it created as a member an object called list, and it's operating on list. Let me spell that correctly. We don't have a list in this particular case. We're operating on ourself. So I will just get rid of this. Okay? So that's the difference between composition and inheritance. That's what inheritance gives us. I will continue. The next method is a get size, public int get size. Alright, so this is from the book using composition. I'm going to get rid of the reference to list. I'm going to just save my work before I get ahead of myself. This is my stack. Alright, the next method is a peek method. Now the book showed it like this. And since I'm not using composition, I will just refer to get. There are two more methods and we'll be done. The next one is a pop. Method that I'm doing now is push for the ones who are following the book. So the push method just adds an object to the array list, and the last one is the string, and we're going to override. Alright, and that will complete 11.10. Let me just compile it just so you guys can make sure we have code that can actually be ran. This is my stack.java. And let's see here. Oh, I don't want to refer to list. No more to list, alright.
How about the list of the
Oh, glad you caught that, thank you. Stack is unchecked. Alright, that's just that's not an error, just a warning. Alright, so we'll be good to go. So this will work, and then we can run it. Of course, we're going to create a main method, but I'm going to do that outside of this recording. So that will complete this lecture.